Thanks, Jocelyn. I'm going to talk a bit about how I think some of the quantification work that a lot of us have been involved in the last few years might align a bit better with solving both the original scientific problems that we started with and maybe some emerging policy problems. There's a lot of people that I've relied on and worked with over the years that have really informed this work. I haven't included them as authors because some of what I'm going to talk about here is really my perspective and in some ways my opinions. I didn't want to impugn all my colleagues with my oddball ideas. But it has to be said that this has relied on my involvement with a number of experiments, excellent experiments, in the last few years. Oh, do I need that one? Okay. It works. So a lot of the motivation for what we're doing in quantifying greenhouse gases, particularly now at the urban level, but originally the pressure mainly came at verification at the nation-state level. This report from the NRC in 2010 really was one of the sort of primary documents that has motivated a lot of this work. And of course, whenever you see a report of this magnitude, that means this discussion was going on for quite a while. In fact, I would argue it's probably at least a decade of interest around better quantification to attempt to support what was going on in the policymaking realm. So over on the right, these are my little icons for Copenhagen on the top, Kyoto on the top, Bonn in the middle in 2001, and then Copenhagen on the bottom. Funny story, the top one in Kyoto, this was an attempt to have a demonstration where these ice penguins were going to melt, but it was an unusually cold year in Kyoto, and frustratingly to the people that did this, the penguins just would not melt. But luckily, in Bonn in 2001, because things were a bit behind that year, a second negotiating session was put together, and this one fortunately occurred in the summer, which usually does not happen. And of course, the big ice sculpture in that case did melt. And luckily, the side of the globe that the United States was sitting on appeared to melt faster. Not sure why that was. I've always been suspicious, but nonetheless. And then finally, Copenhagen. And that process really, in many ways, placed a lot of the policy interest and pressure on the scientific community to engage in verification, because it really was a negotiating barrier. Now, of course, side by side to that emerging and building interest was lots and lots of work within the scientific community. We had been focused on verification in a way, but really an exploration and quantification of fluxes. A lot of our interest, of course, was on that piece of the problem. This is a schematic of one way of going about quantifying fluxes, the inverse method. There are others. But we were focused a lot on the terrestrial biosphere, and the anthropogenic fluxes, which I'm going to talk about next, in some ways were sort of a boundary condition, or even, you could argue, a nuisance to the problem. We typically took them as a known and really spent most of the time attempting to figure out what was going on in the terrestrial biosphere. That work continues, and there's still plenty of questions and plenty of work ongoing. But the policy interest, or I would argue the pressure, began to change through the 2000s for a lot of reasons. You could argue that the international negotiating process was slowing down. It was meeting lots of difficulties. That caused a lot of interest to move away from the nation-state realm and to explore other scales in which you might be able to mitigate greenhouse gases. Lots of cities, not just in the US but all around the world, became much more active in taking on targets, mostly voluntary but sometimes regulatory. Of course, all the work that's going on here in California emerged. And then in the bottom right, I've shown the current proposed EPA rule on power plants, the state-by-state targets. So lots and lots of activity has occurred that's placed a lot more pressure on quantifying fluxes at these smaller scales. At the same time, there's been a recognition, and a lot of this emerged from really new data within the last 10 to 15 years, that the planet is urbanizing rapidly. Quantification of fluxes within the urban areas is recognized now as an extremely dominant part of the anthropogenic emissions. Lots of cities around the world have begun to coordinate their efforts in a kind of a collective effort, a loose collective effort. There's activities going on in China in which there's actual pilot trading schemes between cities and provinces. So lots of movement there. I would also argue that some of the observing techniques on the carbon problem also began to move down to smaller scales. This is a schematic of OCO2, and though it wasn't necessarily originally conceived of as an instrument that would look down at a city, it's possible with its targeting mode that it will be able to do that. And we're looking forward to seeing what that's going to provide at these smaller scales. So a lot of things were happening both within science and policy to push things down to these smaller scales. This has led to a lot of research efforts. I'm just showing examples in the United States. There are examples outside the U.S. Paris in particular comes to mind. We're starting to do a little work with Sao Paulo in Brazil. But these are some experiments that have been ongoing in the U.S. In the upper left is the Influx Indianapolis project. The upper right is some work we've started in Phoenix. In the middle is work that we're doing in Salt Lake City in coordination with people at the University of Utah. The bottom right is the Megacities project, anchored in LA, but reaching out to Sao Paulo and Paris. And then, of course, there's been lots of work ongoing in Boston and now in the Northeast Corridor with colleagues. And there's other work in other cities, but these are what I would consider sort of comprehensive efforts at both measuring the atmosphere, quantifying fluxes from the bottom up, and putting this all together. So the architecture with which this has been done really revolves around, I'm sorry for the voice there, I thought I turned, the volume should be off, but anyway, is a combination of combining these very detailed bottom-up efforts with atmospheric measurements in the bottom right-hand corner, and then, of course, including atmospheric transport, putting these together to try to get a system that can best quantify fluxes at the surface. Love to do it in lots and lots of detail, but there's lots of limits to how well one can do that. This initial architecture was aimed at generating baseline emissions in these locales and probably attempting to verify trends in emissions for the city as kind of a whole dome. That demands lots of accuracy and understanding the uncertainty with which you estimate those fluxes. Pretty high burden, but I think there's tremendous progress in all of these domains that I mentioned a minute ago. So is this what cities really want? And I would argue that there's no question that the verification problem is important. It's a top-level question. It's needed at many, many scales, and I also have no doubt that we're going to be able to do this to the levels that I think are anticipated. There's still work ongoing. We're not quite there, but I'm very optimistic this will happen. However, I would say that in some ways we have to be careful about mapping that nation-state interest down to cities. In many ways, they're working within a very different policy environment, and in a lot of ways have very different questions and very different needs from that conception of the verification problem at the nation-state level. Now, the good news is that in reflection of those different questions and needs, we actually have an awful lot to offer. We've actually already been building it. I think we're just not capitalizing on it a lot, and cities really need it. And this is a paraphrase, I've put it in quotes, but this is a paraphrase of what I've heard from a few cities when I talk to them about what we've been doing. They say, that's great. When we have some mitigation worth verifying, please come back. But right now, we're in desperate need to understand what our emissions are so that we know what to mitigate. Many cities, not all, are stuck in that problem, that they don't know where to begin and they don't have the information and tools with which to understand their emitting landscape. Now, a lot of the work that goes on in cities, a lot of the footprinting that's done, is sort of the pie chart flavor. And there's a lot of work that often goes into these. These can be quite labor intensive for cities to do, but often that's the level at which they're generating the information. I call these sort of zero-dimensional inventories. There's been a lot of work done on protocols, that is defining the boundaries, making it clear what's inside an inventory and out, but not a lot of work on what I consider the hardest part of this problem, which is generating the data. That's where there hasn't been a lot of work, and it's incredibly challenging and difficult. Cities are often underpowered in terms of their human resource to get it done, and resources in general are often very constricted within cities. So can we help? Can the work that we've been doing driven by that initial nation-state verification question, can it help at the city level? And I'm just going to show a couple of quick examples that I hope will suggest that we can offer a lot of help. This is an example in Salt Lake City. This is this sort of very detailed effort that we've engaged in at quantifying emissions down to every little road segment in the city. And the only point I want to make here is that when you begin to look at a city in this level of detail, you often see the tremendous heterogeneity you suspect is there, but it also suggests more efficient policy tools. So in this example, 40% of the emissions in Salt Lake Valley occur on 1.6% of the linear amount of road. In other words, if you were going to engage in mitigation, you might go at this problem with a scalpel rather than a blunt hammer. And if we can deliver this type of information, we may be able to enable cities to do that. Now, underneath this, even though it's often not obvious by looking at these maps, is the important anchoring to the atmospheric measurements. In some ways, I argue this is sort of the pretty face of our system because it talks the language of what an urban planner might think about, since they tend to function at the sort of block-to-block level, but it is very much strengthened by our anchoring with the atmospheric measurements, and that's incredibly important. I'll show one more example, and I'm going to flip through these 3 slides just very quickly, and all I want you to do is just look at the changing patterns. This is the CO2 emissions from the residential sector, again in Salt Lake City. The first one is just the absolute emissions. This one is the emissions per capita, emissions per unit area, okay? And what you see are very distinctly different patterns. And again, if you were engaged in policy, maybe you're interested in improving insulation in parts of the city, maybe in low-income housing, there's lots of things. These patterns become critical to what you might choose to do or how you would go about it. That's, I think, the type of information that cities are interested in, at least the ones that I've talked to. I would argue also that the type of information that we would deliver in this framework has a much lower accuracy burden. Cities don't need to know that that house is 0.001% more emitting than the one over there. That level of accuracy is actually not required. There needs to be detail, and it needs to have some sufficient level of accuracy, and I'm not sure we know what that is yet, but I'm pretty confident that they don't need the type of accuracy that we must bring to that trend detection problem. So I would also finally say that these efforts are best operationalized, they're going to be most actionable when they're aligned with existing problems that cities are facing. And of course, you know, I would say 90% of the people in this room live in cities. We all do, and we know this intuitively. Cities have to fill potholes, they have to pick up the trash, they have to do lots and lots of things. And I don't imagine in the near term that many of them are going to be able to stand up programs on mitigating CO2 irrespective of everything else. Those programs are going to be aligned with things they're already doing, and that mitigation of CO2 is going to be a co-benefit to something they're already engaged in. And of course, cities are engaged in improving air quality, lots of issues around social justice, which have tremendous space-time patterns in cities, things like traffic congestion, et cetera, et cetera. And my point is just that as we begin to do this work or attempt to operationalize what we've done in science, we may want to pay attention to how we might make that most aligned with those other things. So to conclude, I'd say that verification remains an important driver for quantification of greenhouse gas emissions at the urban scale, but that mitigation guidance may be a higher near-term need. It may be something cities need right now, and we have the tools to provide that. The current scientific approach is quite well suited to both sides of that problem, verification and mitigation. I'd say the accuracy burden of the latter is lower, and that's some good news, because we may have less pressure on accuracy. We should co-align these efforts with what's already going on. And I put this up because when talking to a program manager, I became very worried and said, with a quavering voice, does this mean we're doing urban planning? And I said, no, we don't have to become urban planners. We just may want to pay attention to what urban planners are doing so that what we're doing can fit in to what they're engaged in. And so with that, I'll end, and thank you very much.
I think we have time for one very quick question. Okay, if no one else is going to ask, I wanted to ask Kevin, for those of us who do top-down measurements, what would you say would be the most important area to focus on? What would be your priority?
In terms of sectors and,
Yeah.
I mean, most of the cities, the on-road sector is both big, it's both highly aligned with what's going on, because many cities are actively engaged in lots of issues around traffic. And so I'd say if I were going to choose one thing to plunk down on, it'd probably be that. Tends to be numerically large and important from so many fronts that our ability to engage in quantification of that sector probably would lead to the most benefit.